Right, so let's have a look at question 21d from the 2013 Revised Higher Physics paper. This is another relatively tricky question to get right, and there are some pitfalls here. Hopefully you've been following along with the other videos in 21 so you understand what's going on, but it says that the driving force of the motorcycle reaches a maximum value at 5.0 seconds and then remains constant. If you remember back to the previous question, we're talking about the driving force must increase with time to keep a constant acceleration. What we're implying here is that that driving force does increase with time up to a value of 5 seconds. So if we look down at the graph here, because the driving force is increasing, this means that the acceleration is at a constant rate. The slope or the gradient isn't changing, and that will stay like that until 5 seconds. And it is carrying on beyond 4. It's not quite reached 5, which is right in the middle, which is about here somewhere. So it says, sketch the velocity time graph below and extend the graph to show how the velocity of the motorcycle varies between 4 and 10 seconds. Numerical values are not required. So the driving force continues to increase until 5 seconds. That's about here. So I'm just going to put a dot there and draw a line down. Oops, should be straight there. So that's straight. Roughly, I've not drawn that very well. It's very hard without a ruler. I can't put a ruler on a screen, but let's just say that it's about here somewhere, and it goes down to there, and I keep messing it up. But never mind, you get the idea. It travels at a constant speed until about 5 seconds, and then the driving force does not increase anymore, and because of that and this increased air resistance as it's speeding up, that means that the acceleration is going to decrease. The unbalanced force is going to decrease, and therefore the acceleration is going to decrease. So between the 5 and 10 seconds, if our acceleration is to decrease, that means that the line must curve, because the gradient represents the acceleration, and so this changing gradient represents a change in acceleration or a lowering of acceleration. As you can see, the gradient is shallower here than it is over here, so therefore there is less acceleration here. So that's what it should look like. It carries on straight to 5, and then it curves from there onwards away from the velocity axis. Just one other point to note here, it does say in the marking scheme that a sudden change in gradient is wrong, and so what I expect that means is that most people, instead of drawing this nice continued curve like that, what they've actually drawn is it traveling up to 5 and then abruptly changing the gradient, and that's not correct. That can't really happen. It's more of a gradual change.